And for those that are just tuning in, this is lesson 74, number 8. Okay. Now, we're going to FOIL these. Who asked for this problem? Anybody here? So we're going to FOIL that. We're going to FOIL out here. So we get plus 12 root 16. The inner is going to be negative 10, and the last is going to be negative 15 root 8. Okay, you guys good? Aaron, you're not muted. You're like bright and normal. Okay. Yeah, maybe you muted yourself. I just put you back on again, just in case. All right, then once you FOIL that, we're going to FOIL the bottom. And because we multiply by the conjugate, the outer and inner are going to add out. So we're going to get 4 minus 9 times 8. Because root 8 times root 8 is just 8. And then we combine the like terms. If we simplify this up here, square root of 16 is 4. So we're going to have, this is a little piece of work, this guy. 8 is 2 root 2. So let's just clean it up a little bit. So we get 8 root 2. Aaron, are you back yet? 48 minus 10 minus 30 root 2. And then we do the bottom. Whoa. 4 minus 72. Wish we didn't always have technical problems with these classes. They wouldn't be nearly as bad. So we're going to get 38 minus 22 root 2 over 68. And then it's not done yet because you can take 2 into everything. You can take a 2 into this and this and this. So we're going to get 19 minus 11 root 2 over 34. All right, did you get that, Coleman? Wait, Aaron, I think I can hear you. Oh, okay. All right. So that's how you do those. And I think, what was that, Coleman? No? Coleman, did you get that? Whoever's watching this is going to be a disaster. Okay. Next problem is 14. And we might just have to go to the lessons. So 14 is negative x minus, okay, are you humming now, Aaron? 3x squared equals negative 4. So this is a complete the square problem, so it's quadratic, so you set it equal to 0. That means it's quadratic, so you get 3x squared plus x minus 4. You try to factor it, but it doesn't factor, so you have to do complete and square. Or what does it tell us to do? Oh, the quadratic formula. You got to do what it says. So you just can't complete the square. So we know our quadratic formula. You guys memorized it last week, right? Negative b plus or minus b squared, square root of b squared minus 4ac all over 2a. So this is your a, this is your b, which is 1, and this is your c. So just on the chat thing, if you want to chat, go ahead and ask questions or comment or whatever you want to do. So all you do is you fill the numbers in. Why can't you do it? All right, do you get what I did? First, you have to put it in the form. First, you do ax squared plus bx plus c equals 0. First, you have to set it equal to 0. And then a is what's before the x squared. So this is a. B is what's before the x. It just doesn't work. A is 3. B is 1. Okay, well, you watch along with me and see what you did wrong then. So plug them in. So you get negative 1, because b is 1, and it's negative b, plus or minus the square root of b squared, which would be 1, minus 4 times 3 times negative 4. I always just show all my work. I've always done that. 2 times a is 3. Did you guys plug it all in like that? I didn't do anything in my head. I just totally plugged it in. Okay. All right, so Well, all this is plugging in. It's really not that hard. It's just, sometimes you have to simplify the radical though. So then we're going to get 1 plus 16 times 3, which is 48, all over 6. Oh, this is an easy one. So you get negative 1 plus or minus the square root of 49. That's a perfect square, all over 6. And then you get negative 1 plus or minus 7 over 6. And then you get two answers. You're going to get negative 1 plus 7 over 6. And then you're going to get negative 1 minus 7 over 6. So you get 1. You get 1 for the first one. And then the other one you're going to get negative 8/6, which would be negative 4/3. That's it. Those are your two answers. Okay. All right, let's go to another lesson. Let's just do the ones that go with that lesson, just to save time. So lesson 75. Whoops, lesson 75. What would that, where do you have trouble on those? You too? 75? You didn't have any questions? I know Katora wrote one down that she had from lesson 75, but now it's lost in the chat land somewhere. Let's see if I can scroll up. Let's see. It was number 17, you sure? Okay. All right. All right, good. Let's try this one. This one's a little challenging. Did you guys get this one? Yes? No? I can see why you guys don't like online classes. I'm not very good at them. All right. There we go. Nope, what? For some reason, you guys aren't coming in that clearly. Okay, so you're supposed to use similar triangles to find x and y. So what you want to do is draw yourself a similar triangle, like such. It just means that the angles are the same, but the sides are proportional. So you do that, and then you put in here, this is 60, this is 30, and so the ratio is going to be 1 to root 3. So if you're going to find x and y, you just make ratios. So you say this over this, so 8 over root 3 equals x over 2. So you go left to right, x over 2. And then you just cross multiply and you say 16 equals square root of 3x. And then you say x equals 16 divided by root 3. And then you have to rationalize. These aren't nice, are they? So 16 root 3 over 3. And that's how you do it. Without headphones, let's see if you can hear me. Oh, that's never mind. I'm reading my old quote things, thinking it's a new chat box. Okay, I gotta scroll down. Okay, do you guys get that, Coleman and Aaron? So if you're going to get y just for Katora's sake, so you square root 3 over, I get over square root of 3 equals, and now we're going to do y over 1. And then you just cross multiply and get y, which would be this. Oops. There we go. So it's going to be like that. That would be the answer. You have to rationalize. All right. Anything else from 75? You two? Hello? Aaron? 75? Say yes or no. A on 75? Perfect. Okay. Coleman's A in 2. All right. Oh, these are so fun. Okay, this is less. Yeah, I can hear you. Yeah, we have someone has slow internet connection. Oh, you know what? I got a message that I couldn't hear everybody because of slow internet connection. I don't know if it's mine or yours. X plus 5 over 4 minus x. All right, so first thing you want to do is you want to factor the denominators. So you get x, x minus 4, x plus 1. And then we're going to take out the negative 1 here and get x minus 4. That's so that this factor and this factor match. If you take out the negative, it makes them match. So then we find a common denominator, which is x minus 4, x plus 1. This one has both things, so we just write x minus 1. This one, we have a negative and a positive, so it's going to become a negative. Aaron, I can't hear you right now. Maybe you're not talking. This denominator has the x minus 4, but it needs the x plus 1. So we put the x plus 1 here, and that means we're going to FOIL an x plus 1 up here. So you can't forget you have this negative. You almost need to put brackets here. And so we're going to get negative, and then we're going to do our brackets. So we're going to get x squared plus 5x plus x plus 5. And then the final thing we need to do is distribute it through and combine like terms. So we're going to get x minus 1 minus x squared. This is where people mess up. Minus 6x minus 5. I combine these two. All over x minus 4, x plus 1. And then we simplify the top into negative x squared minus 5x minus 4 all over x minus 4, x plus 1. There you go. All right. That's how you do those. The thing you have to be careful of is when you are, we're going to FOIL this, but we still have this negative sign that has to be here to be distributed throughout. All right? My voice is muffled. Is it only muffled? Is it muffled for you too, Aaron? Aaron? Huh. Well, it could be Coleman, your connection. How do people do cyber school with all these complications? Goodness gracious. Because this is the same thing that people use for cyber school. Yeah. Okay. I guess you just get good at it and get, like, they give you the computers and everything that work right. All right, let's go to lesson 76. Can you hear me now? Okay, lesson 76. Do I need to do the practice problem for that? Oh. Okay, let's do 76B. Coleman, do you need A and B or just B? Okay, he needs A and B, so let's do A and B. Okay. All right, let's work this through. So we'll just do the practice problems today and get on to the new lessons real quick. Because cyber school isn't that fun. Minus 3z equals negative 25. Okay, this is a pure substitution problem. So all we're going to do is we're going to take this 3y and we're going to put it wherever the x's are. So we're going to put it right there and we're going to put it right there. So we're going to get 3y plus y plus z equals 56. And then we're going to do 3y minus 2y minus 3z equals negative 25. Where did what go? You guys okay? All right, so you just substitute that in and then you combine these. So we're going to get 4y. At least you can watch if you can't hear me. Plus z equals 56. And then we're going to get y minus 3z equals negative 25. TA? Is that what you guys call Katora? So, Coleman, do you get that? You just substitute in and then we add these together. I didn't know that. So then you multiply, then it's just elimination. So we can multiply this by 3. And so I'm assuming you guys can do it from here. 3z equals Whoops. Yeah, you got it from here? You get 168, and then you get y minus 3z equals negative 25. You get it from here, Coleman? Coleman, do I keep going or do you get it? Okay, 143. Okay. All right, so let's go on to the next problem. This one looks fun. We're going to add two vectors together. So we're going to do negative 2 at negative 15 degrees plus 5 at 110 degrees. These are kind of long. You have to, first of all, put them into the ups and rights, and then you have to add them together. So if we look at this one, if it's a negative, I would draw it out just to see what you're getting. These are tricky. If it's this one right here, that one's easy. Just say x equals 5 cosine of 110. Remember these? And y equals 5 sine of 110. It's the negative one that messes you up. So this one you get, right? You got that. Okay, so let's talk about the negative one. You're going negative 15 degrees, which means you're going down here. But since it's negative, we're going to put in this dotted line because it's not really there. This is negative 2. This is 15 degrees. Negative 15 degrees because it's going the negative direction. Good, Coleman. All right, now because it's negative, it's not really there, so you shoot it through this way. And we work this triangle over here. So we're going to get 2, and we're still going to get 15 degrees. But it's not really 15 degrees, it's whatever this distance is. So you have to take 180, and you subtract 15 from it, and you're going to get 165. So this is going to be 165 degrees. No. Yeah, you have to subtract it because you're getting this distance from the x-axis to over here. So it's 180. So this would be 180 to here, but then we're going to go backwards 15 degrees. So for this one, you would say yes, depending on what quadrant it is in. So you'd say x equals, you would say positive 2, you wouldn't say negative 2. 2 cosine of 165. And this y would be 2 sine of 165. Yeah, and then you just add these two together, and you add these two together. That's one big plus. Yeah, I heard you. That's good. Okay, you got it now? And the last lesson, trying to move us along so we're not here too long. Yeah, let's do the practice problems. Do you need the practice problems for lesson 77? Speak up. Karen, do you B? Okay, this is B. Coleman, how about you? All right, s minus 16 plus square root of f equals 4. So you isolate the biggest radical. Okay, we'll do this one anyway, Coleman. Then we're going to move on to the new lessons in speed time. So we're going to get s minus 16 equals 4 minus root s. So isolate the bigger one. So he gets to be alone. We square him. Whatever we do to one side, we have to do the other, like that. You can't just say 16 minus s. You can't square this and this. You have to square the binomial. So you're going to get s minus 16 equals, now we have to FOIL this guy. So 4 minus square root of s. I got them, but I couldn't do these. Okay. So when it's squaring, it means you're going to take it times itself. So now we FOIL it. 16 minus 8 root s plus s. So I did first, and I got 16. Outer, I got negative 4s. Inner, I got negative 4s, so it's negative 8s. And then the last square root of s times square root of s is just s. Now we isolate this one. So everybody to the left. These guys cross out. That's handy dandy. So you get 32 equals negative 8 square root of s, divide by negative 8. So we get negative 4 equals square root of s, and then we square both sides again, and ta-da, we get s equals 16. That was fun. So this one's a double problem. You have to square it, you get rid of the bigger radical, and then you square it again, isolate the smaller radical, and square it. I got 16. Did you get 16? Yeah. 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 Oh well. Well, when you square, but when you square it, it's positive. Yeah, but when you square it, it's okay. It's all right. Good. All right. So let's see how many lessons we can put through in 20 minutes. Sorry, you have to endure this, but this is how it is. Lesson 78. Okay, this is force vectors on a point. Yay. Okay, these aren't that hard. They're kind of what you did before, but they're in word problem form. So two ropes are attached to a point and pulled on with the directions and magnitude show. What is the resultant force of the points? So what they have here in the book, they have there's a point right here, and you have two things pulling on the point. You have one thing, it's like a rope in the book, but I'm drawing a line because I can't draw ropes. So you have one rope pulling, and it's 70. Yeah, I know. It does. That's 70. The force is 70. Does it tell you what the force is called? Two ropes are attached to a point, pulled on with directions and magnitude. What's the resultant force? Okay, so this one's at 45 degrees. So it's pulling at a force of 70 at 45 degrees. Then there's something else pulling on it. So there's a force of 40. I guess there's no units on these forces. Force of 40, and this one's at 30 degrees. And you have to figure out the total force that's on that point. So all you do is you're going to draw two triangles, and you're going to do your vectors and add them together. It's not terrible, so I'm going to do that. And we're going to do our whole sine cosine jump like we've done all in the past. So let's work with the left side. So we'd say x equals, that's x, is equal to 70 cosine of 45, and y equals 70 sine of 45. You guys get this, right? And x equals 40 cosine of 30 degrees. This is the same thing we've been doing forever and ever. Well, not really. 40 sine of 30 degrees. Pullman, you want to jump in and say something? Why can I hear myself from the past? Okay, so you just put these in your calculator and you get your answers. So this one is 49.5. Whoops, Coleman, you're echoing again. 49.5. They're the same when they're 45. The sine and cosine of 45 degrees are the same. And then over here, we're going to get sine is 20. Use what? You just cut off. 34.64. Yeah. Yeah, you just put them in your calculator. X goes with... Yeah, regular ones in word form, they draw the picture for you, so it's not terrible. So then what you're going to do is you're going to add your x's together. So you're going to add this one and this one together. And when you do that, you're going to get, what? Yeah, we did this before, but there's a twist to these. Exactly. We're add the x's and the y's together. I'm just trying to look for the answer so that I don't have to look them up every time. So it looks like one of these should have been negative. Let's see. I'm trying to use the book for the answer, but that's not good because the book does some weird things. So this value is going to be negative right here because you see if we're on a coordinate system, the direction is going to be negative, so the x one's going to be negative right here. That's the only, oops, not that one. Oops, this one down here is going to be negative. So we're going to add these two together, and for the x's, we're going to say x equals negative 14.857. That's what they have in the book. Then we're going to add our y's together. These are probably one of the most complicated problems we're going to do this year because we're not done yet. Then we're going to add this one and this one together, and we're going to get our y's are 69.50 up. So they want it back in polar form. So this is the same as those problems. Remember those ones where we had negative 14.86 right plus 69.5 up? Well, we're going to go, that's our answer. That's what you would think would be the answer, but now we're going to put it back into polar form. So this is actually the easier part, but it just makes the problem really long. So you add your x's together, add your y's together. Go ahead, Aaron. For some reason you get cut off halfway through what you're saying. So if we add them together and plotted the point, this would be the point negative. Yeah, we're gonna make our, there's our, no. Okay, so we're gonna plot these 2 points. We're gonna plot these points. We're plotting it again, and we're gonna put it back into the form that we started with. So we started in polar form, and we're gonna come back to polar form. So what you do is this side over here, this is 14.86 right here, and this is 69.5. We do the Pythagorean theorem to get the hypotenuse. I know you're all going to hate me for this one. So you get 69.5 squared plus 14.86 squared equals r squared. And you take the square root of both sides and you put it all in your calculator, and you're going to get the resultant, which is the hypotenuse, is 71.07. All right? We'll have to go over these next week, I can tell. Now, this is this distance right here. It's 71.07. Okay, now we have to find theta. So we'd say the tangent of theta equals opposite, which is 69.5, over adjacent, which is 14.86. And then we do the inverse tangent. So we say theta equals the inverse tangent of 69.5 over 14.86. You pop that guy in your calculator, and you get 77.93 degrees. Yeah, it's crazy. It's not undoable, though. It's not an undoable problem, so you write your final answer is 71.07 at 77.93 degrees. That's the answer. So let's just recap. Hopefully the other lessons this week are easier because that takes too long. So you just do your little thing. You've done this for a long time. You do it for this triangle, and you do the same thing for this triangle. Then you add your x's together, you add your y's together, and what that takes you to is this right here. Then you plot the point, and then you do the reverse, where you use the inverse tangent. All right, do your best on that. If you don't get it, we will do it live in class next week. All right. Oh, my. Is it hot in your houses? It's hot here. Crazy. Okay, this is lesson 79. We're doing metric volume. What was that? Are you having trouble hearing me? 45, 45, 90 triangles, which are easier than 30, 60, 90 triangles. Okay, first thing we have to do is metric volume. You have to know this, you have to memorize this. 1 cubic centimeter is equal to 1 milliliter. So it's kind of going from, you know, a centimeter is on a metric stick. So you can measure linearly, like in a line, centimeters. If you took a centimeter and you made it into a cube, like with all the sides like this, where each side is 1 centimeter. Okay, here's a cube. If each side of this cube was 1 centimeter the whole way around, you guys picking up on this? Let's see, where's the other side of 1 centimeter? All right, so if we multiplied these together, we would get a cubic centimeter. And if you poured your liquid into that cubic centimeter, it would be equal to 1 milliliter on a beaker thing. So if this is a liquid container, and it would be, you poured it in, it would be up to 1 milliliter. So what we're doing is we're taking linear units and we're making them into liquid units. So if you poured this in, this is 1 milliliter of liquid, and you poured it in, it would be 1 cubic centimeter. Yeah, isn't that fun? So let's try a problem with these. We're just going to do, let's just do one of these guys. We are going to convert 14,000 milliliters into liters. Oh, that one's not hard. I shouldn't have done this example. Okay, this one has nothing to do with cubic centimeters. Let's just, so this one we know that 1 liter is equal to 1,000 milliliters. That's a unit multiplier. So if we're going to do this one, this is a really easy problem. Let's just do it real quick. This is milliliters. So we would put milliliters down here, 1 liter up here, 1,000. You just multiply that out. This is a little ridiculous. So you're going to get 14 liters. Okay, that one was really easy. Let's hurry up and do the next one. Example 2. I feel like I'm working against the clock here. As usual, right? So this one we're going to do, let's do this one. 4.7 liters to cubic centimeters. I mean cubic inches. Inches cubed. Okay, do you see how we're going from a liquid measure to a linear measure? That's crazy that we can even do that, but we're going to give it a try. So we're going to take 14.7 liters, and we have to get it down to milliliters because we know that in the beginning we talked about this, or we're getting it down to centimeters and milliliters. Okay, 1 milliliter. Keep that in mind. Okay, so we're going to take the liters down to milliliters. So we know that there's 1 liter is 1,000 milliliters. All right, so that was easy enough. Now we're going to take milliliters and we're going to change them into inches. So we know that 1 milliliter is equal to 1 cubic centimeter. So this is where we did our switch. We're going from liquid to linear. So these cross out. Now we have to go from centimeters into inches. And we know that there are 2.54 centimeters in 1 inch, right? We're just going to cube this whole thing, and we're pretty much done. So the answer to this problem is 4.7 times 1,000 all over 2.54 cubed. And it's going to be inches, as these cross out. So it's going to be inches cubed. And that's how you do those. So the only new thing in this is this little unit multiplier. This should have been a cube. 1 centimeter cubed equals 1 milliliter. Okay, 45, 45, 90 triangles. Stay awake. I know it's so hard. All right. Okay, do you remember our 30, 60, 90 degree triangles? I'm going to freehand them because they take less time to draw. Remember these guys? 30, 60. They had a ratio of sides. It's 1, 2, root 3. Okay, this one's a little bit easier. These are 45, 45, 90, even though it doesn't look the same as the other one. We have to depend on this. This is equal, so it's going to be 1, 1, root 2. So we're going to use ratios to do this. So they want us, in this next example, they want us to find x and y. So we make our triangle. and it's going to be 45, 45. I wish I could write meter on this thing. It won't let me. 1, 1, root, oops, that's what's above. It's going to be x, y, and 7. And you have to find x and y. Well, this is our similar triangle because the angles are all the same, so the sides have to be proportional. So we just take the two parts that we know. Let's do top over bottom. So 1 over 7 equals 1 over y. See, I did this over this equals this over this. And we just cross multiply and we say y equals 7. That's it. This is the same as the 30, 60, 90 degree triangles, but you have to memorize this new triangle. It's 1, 1, root 2. Okay, let's find x now. So we do top over bottom, so 1 over 7 equals, now we're going to do, whoops, I did that one wrong. I didn't do this right at all. Go back. Everyone forget what you just saw. Nobody's stopping me. Just hold on a second. I didn't do the ratios right. I did this wrong. All right. I didn't flip my triangle. Like if I flip this guy to look like the other guy, I don't know what I was thinking. So 45, 45. This is 1, 1, root 2. There we go. I flipped it so that they look the same. They look the same. So here we go. Top over bottom. Square root of 2 over 7 equals, let's do x first, 1 over x. There we go, finally. X root 2 equals 7. X equals 7 over root 2. You need to rationalize. So you get 7 root 2 over 2. And that's how you do them. Then you get y. You do the same thing, top over bottom. You have to do hypotenuse goes with hypotenuse. You have to make sure they match. That's what I did wrong. So root 2 over 7. And now we're going to do 1 over y. And they're going to end up being the same thing because it looks the same. So our answer is 7 root 2 over 2. That's all there is to that. Just make ratios, but you have to use this triangle. All right, that's it for that. Let's try to get another one. How much time? We have 5 minutes. I'm just going to give you, it's not Good Friday yet, is it? Nope. So you don't get a day off. Lesson 80. All right, this is, remember direct and indirect variation? All right, so here we go. It says, remember how we did x equals ky? That would be direct variation. And inverse would be x equals, hold on, I have to increase my class time. And then the other one would be x equals y over k for inverse variation. Well, there's another way you can do these problems. It's like this. You can say, I'm just going to write the problem down. A varies directly. Some people like to do it this way better. Directly as B. If A is 50 when B is 5, what is the value? And I'm going to see if I have a video on this. What is the value of A when B is 7? Okay, you could easily do it using this method, but the other method is you would do A1 over A2 equals B1 over B2. And you're like, what does that mean? Well, if A is 50, that would be A1. This is A1. If A1 is 50, so you just put your 50 in there, when B1 is 5. So we're going to put B1 where the 5 is, or 5 where the B1 is. What is the value of A2 when B2 is 7? See how easy this is? A2, we don't have that, when B2 is 7. So when you're reading these problems, the first A you read is your A1. The first B you read is your B1. The second A that you read is your A2, and the second B is the B2. And then you just cross multiply. So you get 350 equals 5A2, and then you just divide and get A2 equals 70. and that's your answer. So it's a little bit easier than using the K's. Do you guys see that? No? Are we doing a lesson today? No, you're not doing a lesson today. Okay, let's do the next example, and then I'll do the, probably have a video for the last one because we need to be done at 12:30. Okay, so example 2, it says cost varies directly as the number purchased. If 12 can be purchased for, this takes me too long to write these down. If 12 can be purchased for $78, how much would 42 cost? How much would 42 cost? Okay, so we're going to do the letters C for cost. So it's C1 over C2 equals the number purchased over N2. Now, if you're going to do inverse for these, you're going to flip the second one around. I shouldn't have done another directed one. If it was inversely, you would flip these two. So now we just follow along and fill in the numbers. So this is the first one. This is the first one. If 12 can be purchased, are you guys there? Hello? You can never tell if you guys are here. If 12 can be purchased for $78, so this is the cost. This is the number. This is your N. This is your N1. This is your N2. And this is your cost 1. So here we go. 78 over cost 2. They don't tell us that. 12 over 78. So, whoops, 42. Because that's your N2. So you just cross multiply and you go da-da and you have your answer. So you would say 12C2 equals 42 times 78, and that's 3,276. And you divide by 12, and you get the cost would be $273. So that's about it for that. It's a lot easier. I'm going to send a video on complex numbers less than 81. I'm really echoing, Coleman, through your headset. So we get, for homework, you're going to do lessons 78, 79, 80, and 81. All right? That's it. So for all you watching on, hopefully that helped, and we'll see you guys next Thursday. All right, bye-bye. Oh no, it didn't record. Is it recorded? I'll do it there.